All right, proportions. If we look at two equivalent fractions, let's say 1/2 and 5/10, note what happens if we multiply diagonally. 2 times 5 gives us 10. 10 times 1 gives us 10. So the cross products are always equal in equivalent fractions. And if you don't believe me, just try another one, like 2/3 and, let's say 4/6. If we multiply diagonally, 3 times 4 is 12, 6 times 2 is 12. This always works out. So the cross products are always equal. Good to know, because that's how we can solve proportions. So since a proportion is two equivalent ratios that we set equal to each other, we just cross multiply to solve. So if you know things are proportional, then you just cross multiply. And maps are supposed to be proportional. And they even have scales on them if you look. There's normally a scale somewhere on a map that tells you maybe the distance in centimeters equals so many kilometers or miles. That means you can use a proportion to find out the real distance. They can also act like a crystal ball, meaning if you know a particular rate and you want to find out what the rate would be after a longer amount of time, you can just use a proportion. So proportions are used for predictions. And for scales, like our map. They're also used for similar figures, but we'll get into that later. Now there are two main ways to solve proportions. We just talked about cross multiplying. That's our first way. So for our first method, if we took 3/4 and we knew that was equal to x over 20, then we could just cross multiply. So 4 times x gives us 4x. 20 times 3 gives us 60. And then we would just divide by 4, divide by 4. And 60 divided by 4 is 15. Another way to remember this is called bottom-top drop. But really, we're just setting the cross products equal. So bottom, top, drop. So you take the bottom number, the 4, multiply it by the top number, the x, and then drop it straight down. Same thing here, 20 times 3, the bottom number times the top, and then drop it straight down. So 20 times 3 is 60. And then just solve it like an equation. Now that's the preferred method, it always works. But method 2, I really like. It's our shortcut. And we all like shortcuts, don't we? Well, sure, when it's that easy, huh? And sometimes it really is. So for our shortcut, all we do is see if one of the numbers goes across from each other, will go into the other number evenly. So let's write our same example down, our 3/4 and our x over 20. And since we know they're equal, we just look across from each other. So the 4 and the 20, 4 will go evenly into 20 5 times. So I just multiply the top and the bottom by 5. And x has to be 15. Because 3 times 5 gives us 15. So again, we just look straight across to see if one number goes evenly into the other number. And this also works using division too. We could have said 20 divided by 5 gives us 4. Now you may want to use that shortcut a lot of the time, but sometimes you'll have to use the cross products way, because you may have numbers that don't go evenly, or you may have really big numbers. Alright, now let's test to see if two ratios are proportional. In other words, you know all four numbers in a proportion, but you just don't know if they're proportional. So we have two methods we can use for this. The first way you might have guessed is we just see if the cross products are the same. So if we had 3/7 equals to 5/12, and we were asked to see if these were proportional to each other, we could just cross multiply. So 7 times 5 gives us 35. 12 times 3 gives us 36. These are not equal, so it's not proportional. And actually, we know since the 36 is bigger, we know that 3/7 is actually bigger than the 5/12. Okay, let's try out method 2. So method 2 says both simplify to the same fraction. For instance, if we had 25 out of 75 equals to 9 over 27, if we just simplified both fractions, so divide them by their greatest common factor, 25 and 75, 25 is my biggest factor, and 25 divided by 25 is 1, 75 divided by 25 is 3, so I get 1/3, and then over here on the right, 9 and 27, 9 will go into both, so I get 9 divided by 9 is 1, and 27 divided by 9 is 3. So these are proportional because they are equal. If they simplify to different fractions, we know they're not proportional. Alright, let's apply what we've learned to solve a couple word problems. Don't act like you saw a monster. Come on now. Or a spider. They're just words. In fact, that's all we do. We just write the words as a ratio. So first write the words or the units as a ratio. In other words, no numbers. Then we want to fill in the two ratios with the numbers in the correct spots. All right, let's get rid of these scary things. Hurrah! It's okay to look. In fact, this word problem is just about a bird flying. See, nothing to be scared about. So let's say this bird flew 4 miles in 12 hours. After 2 days, how far should the bird have traveled? Well, we said we're going to write our words down. So what words do we have here? I see the words miles and hours. I also see days, but I'm going to get to that. So miles and hours, I'm going to write miles over hours. So I just did the first step. I just wrote the words down as a ratio. So miles to hours. Remember, order matters. So if I write miles on top, now when I write my two ratios down, putting them in the correct spots means the miles should go on the top. So I'm going to write 4 miles over 12 hours. Because 4 is miles and 12 is hours. Alright, that sounds easy enough. Now it gets a little tricky here because it says after 2 days. How far should the bird have traveled? Well, 2 days, is that into hours? There's 24 hours in a day, so I'm just doing 24 times 2. So 24 times 2 gives me 48 hours. So if I just plugged in days there and put 2 down, I would get this question wrong. So make sure it's the same unit, and that's why writing that in words really helps to keep you straight. And now it says how far, that's my unknown, so I don't know how many miles the bird traveled. And this is just a prediction. We also have to assume that the bird is traveling the same rate. Hence the word should. So now we could do cross products, but if I look at that 48 times 4, maybe I don't want to do that. There's an easier way. Look across, do the shortcut. 12 will go into 48, and it will go 4 times. So we just do times 4 times 4. We know x is 16 miles. So always look for that shortcut. If the number goes evenly into the other number, you just multiply across. Another time we like to use proportions is when we want to exchange our money. So if we're traveling out of the country. So let's say you wanted to go to Europe and you wanted to know how many euros you could get. So let's say the exchange rate for a dollar is 0.81 euros. How many euros would you get for $73.50? So this happens all the time. If you go into other countries, sometimes you need to use their currency. Well, let's just set it up the same way we did before. And this time we're not going to be scared about it. Funny how little talk of money cheers you up. So here, what are the words that we're dealing with? Dollar and euros. So I could write dollar over euro. And then I'm just going to fill in my two ratios that I know. $1 is 0.81 euros. And that's going to equal, it says how many euros, that means euros is my x, would be $73.50. That goes on the top. So notice the location is very important. How many euros tells me euros is my x. And I just filled in $73.50 for the dollars on the top. Now this one we can't use equivalent fractions for, or at least not very easily. So we're just going to use cross products. So cross multiply, and yes, you can use a calculator for this one. And when we multiply, we get about 59.535 equals 1x. So that's our exchange rate. The dollar is every 0.81 euros, so if we had $73.50, we would have a little over 59 euros. Notice we didn't need to divide there because it was just x times 1. So there was no coefficient in front of the x, so in other words, nothing to divide by. It was just one step. And that wraps up proportions.